NASA's racing to return humans to the moon in 2 years, but critical pieces are still missing, and deadlines keep slipping. What changed? SpaceX just revealed 3 brilliant shortcuts that could make the mission simpler and faster than NASA's plan. We're talking cut refueling by half, eliminate dead weight, and rethink lunar orbit entirely. Could this beat China to the moon? Let's find out on today's episode of New Space Review. Let me explain the mess SpaceX is trying to untangle. Right now, the plan calls for launching a depot Starship into orbit, then sending up tanker after tanker to fill it. Once it's loaded, the lunar lander launches, gets refueled, and heads to the moon. Sounds straightforward, right? Except nobody knows how many tanker flights this actually takes. Some estimates say 8, others say 15. Until there's real performance data from orbit, it's all guesswork. That uncertainty is killing NASA. SpaceX has been quietly working on what they call a simplified mission architecture. When you break down what that means, 3 very different solutions emerge. Each one attacks the refueling problem from a completely different angle. The first one almost sounds too obvious. What if Starship just didn't come back? The entire upper stage right now is built for full reusability. Heat shield tiles, massive grid fins, header tanks, complex guidance systems. All that hardware adds tons of weight and burns fuel just hauling itself around. But throw away the upper stage? The math changes instantly. An expendable Starship strips out everything. No flaps, no tiles, no re-entry systems. You still recover the booster where the expensive Raptor engines are, but the upper stage is one way. SpaceX estimates this could cut tanker missions by 50%. Fewer launches means fewer things that can go wrong. Sure, the cost goes up because you're ditching hardware, but Saturn V didn't come back. The shuttle's external tank didn't come back. We've been flying expendable rockets for 60 years. Maybe SpaceX moved too fast trying to make everything reusable from day one. An expendable upper stage could have gotten payloads to orbit years earlier. Sometimes the simple path wins. The second solution flips everything. Instead of throwing away hardware to boost performance, what if the lander was just smaller? Way smaller. Current Starship HLS hauls all those Raptor engines and massive fuel tanks just to perform the translunar injection burn, the big push from Earth orbit to the moon. Once that burn is done, you're carrying 30 to 40 tons of dead weight through every maneuver. Descent, landing, ascent, return. That's a brutal efficiency penalty. The Stubby Starship concept solves this by not doing its own TLI burn at all. You launch a shorter lander to low Earth orbit and dock it with a separate translunar tug. The tug does the heavy lifting to get you to the moon, then separates. From there, the Stubby lander only needs about 400 tons of propellant for everything else, round trip between lunar orbit and the surface. The weight savings cascade everywhere. Lower dry mass means better fuel economy. A shorter vehicle has a lower center of gravity, so landing is more stable and the crew elevator gets simpler. Delta V margin jumps to nearly 700 meters per second. Mission planners get real breathing room. Most important, way fewer tanker launches because the lander itself is so much lighter. There's a catch, obviously. You're now doing a high-energy burn with 2 massive spacecraft docked nose to nose. Nobody's ever tried that. The docking system has to survive multi-minute burns under full thrust. The guidance software can't have a single bug. One miscalculation in deep space, and it's over. But look past the technical risk for a second. This architecture sets you up with two vehicle types: a lightweight crew shuttle for quick surface runs and a heavy cargo hauler for one-way deliveries. That's not just a moon strategy, it's the foundation for Mars. You're building a system, not a one-off vehicle. Now, the third idea is where SpaceX really goes off script. They're calling it the Star Kicker. Picture a second stage with no nose cone, no payload bay, just engines and fuel tanks. You stack a full Starship on top. Basically, you're building a three-stage rocket in orbit instead of on the launch pad. Launch the lunar Starship and refuel it. Separately, launch the Star Kicker and fill that too. Dock them together, Star Kicker on the bottom, acting as a giant booster stage. When the crew's aboard and everything's locked, the Star Kicker fires everything it has. Direct shot to the moon, maybe even straight into lunar orbit. After that burn, the Star Kicker is spent. It's stuck in some weird orbit, expendable for that mission. The lunar Starship continues alone, does the landing, handles the surface mission, then flies all the way back to Earth orbit on its own fuel. No separate ascent vehicle, just raw thrust and a massive fuel load. This is Lego block engineering applied to spacecraft. Once you're comfortable refueling in orbit, you can mix and match stages for different missions. Need more Delta V? Add a Star Kicker. Don't need it? Skip it. The flexibility is the entire point. What SpaceX is really saying here is that the original mission design is too complicated. So, instead of one solution, they're throwing out three completely different architectures. That tells you something about where NASA's plan stands. It also shows why SpaceX is so dangerous as a competitor. They're not married to any single approach. They're exploring every option simultaneously. Blue Origin's playing this differently. Their Blue Moon Mark II lander takes a more traditional route. It's still ambitious, still needs refueling, but everything operates at a more manageable scale. The lander runs on hydrogen-oxygen propellant, delivered by at least 4 tanker flights, and a reusable cislunar transporter. The problem? Before Blue Moon carries its first crew, Blue Origin has to finish developing 3 major vehicles: the lander, the tanker, and the transporter. Each one has its own timeline and technical hurdles. There's a clever workaround floating around, though. Use an expendable Starship to lift a complete Blue Moon stack into low Earth orbit. That stack would include a fully fueled Centaur 5 upper stage as the departure stage, with Blue Moon mounted on top. Strip 3 tons of dry mass from Blue Moon, and Centaur 5 can push the whole thing to the moon without any additional refueling. The crew launches on Orion, docks directly with Blue Moon in lunar orbit, no gateway required, lands, does the mission, and comes home. It's cleaner than the current Artemis plan because you're cutting out pieces instead of adding them. What I respect about Blue Origin's approach is the realism. They're not trying to revolutionize 6 things at once. They're building on proven technology, scaling carefully, and accepting that some challenges like orbital refueling just take time to solve properly. But here's the uncomfortable truth nobody wants to say out loud. NASA has 2 goals that might be pulling in opposite directions. First, beat China to planting boots on the lunar South Pole. Second, establish a permanent human presence that lasts decades. The first goal? Probably already lost. US politics grinds everything to a crawl. China moves with singular focus and clear direction. But the second goal is the real prize. Whoever figures out continuous lunar operations owns the future. The most efficient path forward might hurt to admit. Ditch SLS, ditch Orion, ditch Gateway. Go all in on SpaceX. Put every dollar and engineer toward making Starship work, because it's the only system with the capacity and cost structure to sustain long-term operations. Elon Musk basically said this when he responded to analyst Michael Duffy. Starship will end up doing the whole moon mission, mark my words. That's not bravado. It's a bet that everything else will prove too slow or too expensive to keep up. SpaceX isn't offering one solution. They're offering three, each tackling refueling differently. What matters? They're building permanent infrastructure, not just flag-planting missions. Will it work? The next year decides everything. Like and subscribe to New Space Review if this helped. Which approach makes sense to you? Comment below. Want to see Ship 39's upgrades making this real? Tap the screen now. SpaceX's new Ship 39 heat shield shocked NASA. Ready for Mechazilla. Thanks for watching. See you next time.